In this lecture, we will discuss how to find refractive index of a liquid using concave mirror. So let us say we have a concave mirror, and this concave mirror is filled with the liquid for which we have to find out the refractive index. Let us say refractive index of liquid is mu. So we have to find value of mu. So we have to find the value for mu. This is the principal axis of this mirror. Now let us say a object is translated along this principal axis, and this object is translated till the image and object coincide. So we have to search a point on this axis for which object and image both lie at same point on the axis. So this is the image and this is object. So we have to search a point on axis for which object and image coincide. Object and image coincides. This means the incident ray and reflected ray are same. That is, reflected ray follow the same path that is followed by the incident ray. And this is possible only if the ray is normally incident on the mirror. If a ray normally incident on the mirror, it retraces its path. So since object and image are coinciding, this means the incident ray is normally falling on the mirror. So let us say what is happening here. So we have an incident ray, and this incident ray is normally falling on this mirror. We can make another diagram. So let us show this one. So let us make this liquid level is slightly more so that we can show the ray clearly. So a ray is coming here, or we can say a ray is coming here. So now this ray is falling normally onto this mirror. This means if I extend this ray in the backward direction, it will pass through the center of the mirror. So this is center. This is because if ray is normal to the mirror, this must be coming from the center, then only it will be normal. So this retraces its path. Let us call this angle, that is angle of incidence, is I. So this angle is I. And this angle, that is angle of refraction, let us call this angle is R. So we have this angle is R. So what is happening, we can show clearly here. So light ray is coming here and this is bending in this direction. So this angle is I and this angle is R. Now we are extending this line this side. So this angle is also equals to R, because these and 2 are opposite angles. And this angle will also be R, because this is alternate angle. If things are not clear, we can show another diagram. So this light is incident. This is falling normally, so that it retraces its path. This is normal on this surface. This angle of incidence is I. Now if we reproduce this angle, this line, it has to pass through the center of this mirror. So this angle is, basically this angle is R, that is angle of refraction. Now this angle and this angle are alternate angles, so this angle is also equals to R, opposite angle basically. Now this one and this one are alternate angles, so this is also equals to R. Now let us call this point is C. This point is same point where we have object and image are coinciding. So this side we have image and this side we have object. So this is a point where we have object and image are coinciding. So let us call this point is O, this point is P, this point is M, and this point is N, that is intersection. Let us say height of water that is filled inside this is T. So T is the thickness of water, thickness or height of water level. Refractive index of water is mu. Now on this surface we can apply Snell's law. Refractive index of this side is 1 because this is air. So mu into sin I, mu is 1 for this case, is equals to mu into sin R. This side mu is mu sin R. So from here we can write mu is equals to sin I by sin R. Now these angles are small, I and R are small. Basically these rays are paraxial rays. So these rays are very close to the axis. So rays are paraxial. So we can assume I and R are very small. So we can write sin I is equals to tan I, and similarly sin R is equals to tan R. So we can write mu is equals to tan I by tan R. Now let us calculate value of tan I from this triangle. So this angle is I, so this angle is also I. So tan I is OM and this is NM. So NM by OM. Tan R, that is NM divided by CM. So we can write NM by OM into NM by CM. So NM goes. So we will have mu is equals to CM by OM. Now this distance can be measured. So what is the position of object? So this distance can be measured from experiment. Let us say this distance is D. So we can calculate OM is equals to D minus T. And we need CM. Basically CP is R. So we can calculate CM is equals to CP minus T. And CP distance is nothing but radius of curvature of mirror R minus T, where R is radius of curvature of mirror. So we can write CM is nothing but R minus T and OM is nothing but D minus T. So we can write refractive index of liquid is R minus T divided by D minus T. In some special cases, if level of liquid is very low, the thickness is very small. So in these cases mu is directly equals to R by D. So using this method we can calculate refractive index of any liquid. So only important point we have that my experiment should be such that object and image should coincide. We have to search for this point, so we have to translate this object along this axis till the date we have object and image coinciding.